Good morning, friends. Partial replacement of cement using silica, fume, and metakaolin is our project title, and it is done an in-house project in Veltech. Uh, we are batch number 6. The member students are Gautam K, Kadirvel V, and Prabhu S with Rukesh C. Our project guide is Mr. M. Vignesh Kumar M Tech. Here is our abstract. In the construction industry, mainly the production of Portland cement will cause the emission of pollutants, resulting in environmental pollution, which is reduced by using industrial byproducts such as silica fume and metakaolin. In this work, various trials with varying percentage of silica fume and metakaolin are carried out. We are based on the parameters such as workability and compressive strength of concrete. The properties are studied. The result is here is our aim. The aim of the project is to uh, is with environmental concerns, that is the emission of pollutants, and partially replace the cementitious material to offer considerable strength. The objective of this study is to produce high strength concrete, and by addition of some pozzolanic material, the workability, durability, and the strength resistance to cracks are increased to reduce emission of pollutants and to increase the lifespan of concrete. This is our objective. The material used is silica fume. The property of silica fume is a byproduct from reduction of high purity quartz with coal or coke. And here is the picture of silica fume. It contains silica as the main content, and the other material is metakaolin, which is a pozzolanic material from selected kaolins after refinement. And here is the picture of metakaolin. This reaction takes place when metakaolin is added to cement. We are using an admixture called Conplast SP430, and is used for a high degree of workability, and the main advantages is it improves the workability, improved quality, higher cohesion. And here is a picture of Conplast SP430. The flowchart explains about the literature review, from which the selection of industrial byproducts is estimated, and the mixed design ratio calculation is computed, and trials with varying percentage of silica fume and metakaolin are carried out. With this, fresh concrete is made. The workability and casting of cubes are done. Curing is done for 7 day, 14 day, and 20 day. The compressive strength test and split tensile test are carried out, where the output is shown in graph and calculation, and the conclusion. Experimentation. The experimentation is workability, that is a slump test, and strength for compressive and split tensile test. The mold size is cube 150 by 150 by 150, and cylinder size radius 100, and height is the specific gravity test. This is carried out, is also known as relative density, and the formula for specific gravity is W2 minus W1 by W4 minus W1 minus W3 minus W2. This ratio of the mass of a solid or a liquid to the mass of an equal volume of distilled water under prescribed temperature and pressure is called specific gravity. This is carried out for coarse aggregate as well as here we have shown for the specific gravity test for fine aggregate, the same calculation. And based on these grading limits of fine aggregate, IS 383 1970, the confirming zone is 2 of table 4. Slump test. We obtain slump of nearly less than 50 for all concrete mix. And slump test is a method for finding the workability of concrete. It consists of a metallic mold in the form of a frustum of cone, having the internal dimensions as bottom diameter 20 cm, top diameter 10 cm, height 30 cm. And we got all the slump value since it is a M40 grade. The water absorption test is carried out, where weight of the aggregates in dry condition is measured for a unit mass and then submerged in distilled water for at least hours in a mesh bucket. Then weight of the aggregates is measured in wet condition. The ratio increase of weight of aggregate in wet condition to the weight of the aggregate in dry condition. Here is the mesh bucket. The water absorption test is carried out for also. And here is our mix design. The test data. Cement used is OPC 43 grade for M40 grade, and it is obtained from Penna cement. And these are specific gravity and other related industrial byproducts. And here is our concrete mix, which is mixed for the sieve analysis, and target strength is based on the formula given that FCK plus 1.65 years, where S is the standard deviation, where it is explained as a 5 for M40 in table 1 of IS 10262. So therefore the target strength is 48.25 Newton per mm square for M40, and hence we have adopted a water cement ratio 0.40, and selection of cementitious material based on the water content is 140 is 370 kg per meter cube, 146 by 0.4, and partial factor of safety of 1.1 is used for cementitious material, which describes 407 kg per meter cube. And so water cement ratio is thus obtained after using Conplast SP430 is 0.358 as a water reducing advantage. And here is the mix calculation for volume of cement, volume of water, and volume of mass of coarse aggregate and mass of fine aggregate. Here is our mix design, mix proportion. Cement 407, water 146, fine aggregate 711, coarse aggregate 1179, chemical admixture 7 ml per kg, water cement ratio 0.36. And this is the sample calculation for 5% of silica fume and 20% of metakaolin replacement. And this is the table explains about 5% replacement with 20%. This is the table for compressive strength. The maximum is obtained at 520 replacement, that is on 5th, that is the ratio mix of silica fume 5% and metakaolin 20%, yields the maximum 28-day 50.27. And here is our compressive testing machine, where compression of cube is done. Here is our graph showing 5% replacement with varying percentage of metakaolin. The maximum is obtained on 3, that is the 28-day strength is 50. Then next is the compressive strength for 10% silica fume and varying percentage of metakaolin, where compressive strength and percentage replacement are shown in graph. This is for 10% and varying percent. And here is the inference from the graph. The maximum is obtained for M40 without mixing pozzolanic material, it is 44.62, and when silica fume and metakaolin are admixture for 5 and 15, it is 46, where there is an increase of compressive strength 4.012 when compared with conventional concrete, and 25% replacement, that is 50.27. This is the maximum one, where a compressive strength is increased by 12.67. So 520 is the can be taken as an optimum dosage, which can be mixed as a partial replacement. And here is the split tensile strength, which is carried out in compressive testing machine. Here is the results of table for split tensile strength, where the maximum is obtained on 520 ratio, the same of silica fume and metakaolin, that is 3.773. Here is the graph explaining the 2.952 is the optimum conventional concrete, and the split tensile is maximum at 3, 20 days is 3.77. Here is the sprint tensile strength for 10% silica fume and varying percentage of metakaolin, where the 28-day strength is maximum results. The 28-day strength of concrete generally increases with the metakaolin content, but thereafter it declines when its optimum content is reached. The 7-day compressive strength of concrete generally decreases with the increase of metakaolin at all the silica fume contents. The 520 is the optimum dosage for silica fume and metakaolin for 7-day, 14-day, and 28-day compressive strength. The slump is found to be with increase in metakaolin content. Here is our conclusion. The maximum compressive strength and split tensile strength were found at 25% replacement, which is discussed from the results. Strength is found to be more than conventional concrete, thus it can be used in various applications. As the materials which are used are industrial byproducts, it is cheap, and here are our references, and